one equation. What equation did Jerzy solve? Explain how to verify your equation is correct. So we have this equation here now, and we are looking to see what equation has this line here and what equation has the V shape. We already know this is a linear function or linear equation. And first of all, let's find here the slope. We already see this point here intersecting the y-intersection, and this point here we see is -3 but goes up to here. And if we are finding informally the slope, so the rise here is 1 unit, 2, 3, 4, 5, 6. So the rise is 6 units. And if we are looking here, the run is 1, 2, 3, the run is 3 units. And if we are looking now, informally, we want to find the slope, so m is equal with the 6 divided by 3. So the rise divided by run. And because of this slope here, in this side, is increasing from the left to the right, so it means this is a positive, and the slope is a positive 2. So m is equal with 2. And now let me go a little bit low. But let me write here again, m is equal with 2. So this is the slope. But on the other hand, if we are looking here, for example, the y-intercept, so the y-intercept is 3 units. So 1, 2, 3 units. So the y-intercept, so let's say b is equal with 3. And if we are taking the equation of the slope-intercept form, y is equal with mx plus b. So y is going to be equal. So m is equal with 2. And here is x plus the y-intercept b is equal with 3. So we already found one equation here. So let's say this is equation 1. And now we are looking to find this equation here. If we are looking at this equation here, we already see this is with the absolute value equation. And we already know the parent function of absolute value equations is, let me write the different color, is y is equal with absolute value of the x. So this is the parent function. But if we are looking here, for example, this one, what kind of the function, what kind of transformation is here, we already see the parent function moved 1 unit to the left and 1 unit down. But this is, and we have a reflection over x-axis because this is upside down. And we already know for the parent function, for example, if we are writing here, it's going to be something in the V shape, in this form. So I'm writing just this, and it moves 1 unit to the left, 1 unit down, and is a reflection over x-axis. And if I write now this equation is going to be as follows. So as we said, so the y here, we have a reflection over x-axis. Let me write here a minus. And we have a 1 unit to the left. So we write here inside the absolute value plus 1. And we have 1 unit down, minus 1. So we already found this equation. But this equation here represents both the lines. So this line here and the other line. But what we see here in the intercept, so just let me put a little bit up. So in the intercept, we have adjusted this left side of the absolute value function that they intercept. They are not intercepting on this side. So as we see this side here, the slope is a positive. Okay, so keep in mind this is a positive. And now, okay, so just let me go a little bit up. So this function here, we can have two equations. So y is equal to the minus x plus 1, minus 1, and we have a y is equal to the x plus 1, minus 1. But this function, this part of the absolute value function has a negative slope, but we are looking for the positive slope, so this one here. So let me take this equation here and let me create a system of the linear equations. If I'm creating a system of the linear equations of the equation 1 and equation 2, we are going to have, so y is going to be equal to the 2x plus 3, and the y is going to be equal with the x plus 1 minus 1. So this system of the equation is going to provide us with with this point of intersection here, that we got this intersection of these 2 points. And now, so this is the equation. But anyway, if we want to, for example, just to prove it, but just let me frame this equation here because this is the answer. If we want to, for example, to prove it, this one equation is, those equations are, this system of linear equation is correct. Let me make one equation. So let the equation 1 is equal to the equation 2. And let's say here 2x plus 3. So let me write the different color. So 2x plus 3 is equal with x plus 1 minus 1. So 2x plus 3 is equal x plus 1 minus 1. So plus 1 minus 1 is 0 if we have an x here. So minus x both sides and minus x here. This we can cancel. And 2x minus x, so let me go a little bit up. 2x minus x is just a x plus 3. And in the other side is a 0. Minus 3 both sides. Minus 3, this we can cancel. So x is equal with the minus 3. So we found the x. And now if we are plugging in x in any equation here, 2x plus 3, we can get the y is equal with 2 times minus 3 plus 3. And 2 times minus 3 is going to be equal with a negative 6 plus 3. This is equal with a minus 3. So, and the y here is equal with a minus 3. So we already verified this. This equation is going to give the points, the solution of the x is minus 3 and y is equal to minus 3. So this linear equations, system of equations, gives the solution minus 3 and 3, which is the solution here.